Hey everybody! Good to see you. So today we are going to be dividing our radicals. Some of this will be review, some of this may be new, so let's get ready to rumble. Alright, so first we will divide the coefficients or any of these numbers that'll be out front of your radicals. So it's kind of like multiplying. We treat them separately, so we're going to treat our numbers separately as a separate fraction.
Marley and Hazel, please come to the front office and see Miss Elizabeth. Thank you.
Girls running around the hallway. Oh, well, it would help if I waited on this for a second before I explain this. So we have the quotient rule. And the quotient rule says that if you have the same index for two radicals, on the numerator and denominator, that you can combine them and make one radical as a fraction under the radical, like this. So that means in number one, they are both square roots, so we can go ahead and put them under one big square root and make that fraction. And then simplify the fraction first before you worry about the square root. That's my best tip. And then, of course, after that, we simplify. So these will be pretty self-explanatory, but again, breaking it into two parts is helpful. So 12 divided by 2 will give you your 6. And then do this part. So in your calculator, 160 divided by 5 is 32. So that means I have radical 32. And you're like, yay, I'm done. Ooh. Look at that number. So we have to combine our simplifying from section 1 also into this. So yeah, just because we're doing operations and then we do the operation and simplify the parts doesn't mean we're necessarily done, especially right here with our radicals. So this is kind of a large radical. So let's see what that breaks down into. That is 8 and 4. And 8 is always going to be 2, 2, 2. And 4 is always going to be 2 and 2. So we're not worried about the 8 and 4 anymore. Let's circle our pairs. Pair of 2's and another pair of 2's and then a single 2. So carrying that up here will be a 6 times. Okay, so take out any pairs. Any pairs would be a 2 and a 2. 2 times 2. And then our singles go under the radical, which is 2. Of course, you can do this step in the calculator instead of doing the factor tree. That's fine. The 32 divided by x squared, and then look in your table. And you should get 4 radical 2, because these two come out to be 4. So that's what you would get in the calculator. But, of course, we can do it like this as well. 4 times 6 is 24. Radical 2. Now, this is a prime number that doesn't have any square roots. So, again, I noticed this right away. 32 had a factor of 4. 4 is a perfect square, so that's why I knew that, okay, 32 is not completely simplified. So that is your solution. So break them down into separate animals. Let's go ahead and do number 2 since we have a 4th root in here. So again, we're going to do 36 and 9. Just worry about them. 36 divided by 9. And then our radical will become 1. 4th root of 1250 divided by 2. And then we work each one separately. 36 divided by 9 is 4. 4th root of, that would be what, 625? Yeah. 4th root of 625. Okay, now we need to see if 625, now it could come out and be, let's pull up Desmos. So 4th root of 625, oh, comes out to be a whole number, and that's why it's always a good idea to check first to see if it comes out to be a whole number, just in case. And now I know I don't have to do the division one, the 625 divided by x to the 4th. I don't have to do that. You only do that when you get a decimal, okay? So we just checked to see if it simplified right out, and so it gave me 5. So all of this right here can change to a 5, so that gives me 4 times 5, which is 20. Okay, hopefully that makes sense to you guys. We got some with variables in here. We've got one with a negative. Let's just go ahead and do number 4, and then I think I'll let you do the others if we can. Well, no, because there's going to be some interesting stuff going on down here. Just, I think we'll be alright if we leave this with number 4. Let me see what we did last time. Yeah, let's just do number 4. Why not? Alright. So we have those we got to do. Okay, I know I can take out this negative, so let's just go ahead and put that negative way out front so I don't get confused with it. It's a good idea, and you can do that, of course, whenever you have a third or odd root. Okay. Ooh, there's something in my eye. My eye itches. Okay, -7. Alright, I got a couple things. Now I have another kind of split here. Okay, but go ahead and we're still going to worry about simplifying everything underneath first. So 6 divided by 2, 16 divided by 2 gives me 8. And m6 divided by m, remember when you divide variables that you subtract their exponents, the top minus the bottom. So this is really a 1. So 6 minus 1 means it's m to the 5th. And then I keep my root of 3, 8, m to the 5th. Okay. And then I believe I have more simplifying to do. Yes, I do. I can tell right now the third root of 8 is 2. So I'm going to have to do that. So that'd be -7. And this is again where I'm saying you can split this up. So split this up. If it helps, do each one separately. So you have -7 times the third root of 8 and times the third root of m to the 5th. Breaking up my numbers and my variables and doing them separately can help. Okay? So third root of 8 is 2. And then we take out a group of 3 of 5, and so that would be one group of m, one group of 3. And then we have leftovers. So if we take out 3, we are left with 2 of them. Now simplifying everything together, -14m, third root of m squared. So if this number is smaller than this number, you're fine. You're simplified and you can't do anything else. And that is the answer. So we are good with that. Okay, so just keep that in mind with these. When you start by doing this one, you're going to have x third, and I'll just show you this one again just because I think we haven't done very many of these. And then do the y's. So to simplify this first, you subtract them. So this would simplify to 3 minus 2. It's always the top minus the bottom. And that would give you a single x. So radical x, and then you can go ahead and do that one. And then this will simplify even more. Well, let's just finish it. Why not? It's like, we're almost done. Might as well just finish it, right? 9 minus 5 is 4. But since this is squared root, we can take out groups of 2. Okay? So how many groups of 2 can we take out? 2. And they'll be even. So we can take out 2 groups of y's. Then all of this goes away because there's no leftovers. And then you still have your radical x, and just tack that on at the end. So y squared radical x is the correct answer. All right. Let's see. I think with these, yeah, I think you're good on those. You're good on that one. Just do third root on that one. There might be some that are going to be kind of tricky. Let's start number 8, just to make sure we're good. Alright, so let's do, first let's simplify 32 divided by 81. Let's see, 32 divided by 81. I know that's going to be a decimal, but it can simplify. Oh, no, it cannot simplify even more. Alright, so this is one kind of different. 32 over 81 does not simplify anymore. So the challenge now is you can go the other way and break them up as separate. So let's try this. Let's see if we can do 4th root of 32. And I know that I'm going to have the W. That's the only W. I'm just going to leave it in there. And see if they come out separate. So 4th root of 32. Nope. What about 81? Oh, 4th root of 81 is 3. Okay. So that one came out. So I can change the denominator to just a 3. But I'm still left with this. So what that means is I need to check my 32 to see if it can be simplified anymore. And we actually did that previously, didn't we? Oh, no, it was square root. It wasn't 4th root. Okay. So let's see if this will, yes, it will break down. Okay, 4th root of 32. Now we're going to go back and do our little trick. 32 divided by x to the 4th. Ooh, we got a 2 and a 2, and I'm pretty sure that that's all we're going to need is 2 and 2.
A big shout out to Miss A, Mr.
So that was 2 radical 2. So that's just this part right here.
A shout out to Mr.
Wow, okay. Let's try that again. 2, 4th root of, and it was 2, and we still have that W in there, so we can just leave that. And then divided by 3. And that is it. That's all we can do, okay? So a lot of things to look out for, different things to try. So like I was saying, you can put them together and see if you can simplify that fraction, or like in this case, breaking them up was actually a little bit easier. So either way works, okay? And then just remember that when you have those big numbers under those radicals, you need to check to see if they come out to be a whole number, or remember to do this to get your simplified radical. So this number on the outside and this number on the inside of your square root, which is what worked out for this case, okay? So I would take off partial credit for if you just left it like this, because you didn't simplify the radical 30, the 4th root of 32. So keep that in mind, that you want to check everything and be careful and thorough. All right, so I think I want to let you try these 3. So go ahead and pause the video and then press play when you are ready to see. Alrighty, here you go. Here's the answers to 5, 6, and 7. Feel free to pause the video if needed. I'm going to go ahead and go to the second section, rationalizing the denominator. Alright, so this should sound familiar, considering that we have all had geometry. Yes, we did some of this in geometry. Alright, let's see what we got. Okay, so to start out, just discussing the different denominators you're going to have. A monomial, which is 1 term, and binomials 2 terms. So the monomial denominators you will multiply by the numerator and denominator by its radical. If you have a binomial denominator, you'll multiply by the conjugate, okay? So a monomial is just like radical 5. Example of a binomial one is like 1 plus radical 5, okay? So this means that in this case, you would multiply it by itself. Let's use a different color to kind of indicate. So in result, you would multiply it by itself. But in this case, you would multiply it by its conjugate, and the conjugate is the opposite sign in the middle. So all that is, which is said, the same expression, but with the opposite sign, so 1 minus radical 5. Okay? So that's the idea, and you'll see what I mean when we actually do an example. Alright, let's get started. So number 9. So what is wrong? Okay, just to review, rationalizing the denominator, no radicals in denominator ever. that is improper, okay? It's improper to have a radical in the denominator, so the whole point of doing this is to get rid of it and make it, all we're doing is making it look different. Okay, so in this case, just like what I did here, you would multiply it by the numerator and denominator of whatever radical you're trying to get rid of. So since we're getting rid of radical 5, we don't want it, we multiply it by the top, and we multiply it on the bottom. Because essentially, when we're allowed to do this because this whole expression right here is really 1. And if we are multiplying something by 1, we are not changing its value. We are just changing how it looks. So, remember when we multiply fractions, we just go straight across the top, straight across the bottom. So, 3 times radical 5. We cannot combine those, so we just leave them as such. And then this is what happens. These two will cancel each other as far as the not really get rid of them, but it'll eliminate the radicals. So we still have to keep the 2, but the radical goes away because the radical of 5 times the radical of 5 is 5. Just to review that. Let me show you what I mean. Any radical times itself is always that number. Okay, just like this. Always. That's always the case. So that means the radical goes away, and we are just left with the 5. So 3 radical 5 over 10. And then from there, just make sure 3 and 10 don't reduce, and no, they do not. So that is the answer. Okay? All right. Let's do this one. So this will convert to radical 8 and radical 15. If needed, you could simplify one of those, but no, we can't. This is 3 and 5, and they're both prime. So we still want to get rid of this radical in the bottom because that is not allowed. So like over here, the radical we're trying to get rid of is what we multiply the top and the bottom by. So we have radical of, what's 8 times 15? 8 times 15 is 120. And then 15 times 15, the radicals cancel, and we're just left with 15. Okay? Are we done? No, we still have this big number under the square root. So let's put that, and I know that's not a perfect square, so let's do my little trick here. Divided by x squared. 2 and 30. All right, 30 is still a big number, so I'm going to keep going, see if I get any more. Am I not going to get any more? I guess not, because I'm getting closer to 1. So it's 2 and 30, which is 5. Okay, 30 is 5 and 6, and 6 breaks down to 2 and 3. Yeah, there's no more perfect squares left in there. So it is 2 and 30, okay? So it doesn't hurt to check, though. 2 and 30. So that becomes 2 radical 30. And you could, of course, do the factor tree instead, and that would be fine. All right, so that's the numerator simplified to 2 radical 30. And then we just see if 2 and 15 reduce, and no, they do not. So that is the answer. Alrighty. So that's getting you started on rationalizing the denominator. Alright. That one should be the same we already did. Okay, here we have a variable. So, let's see. There's a couple ways we can go about this. Let's go ahead and do this one. Number 12, since we're throwing in variables. Alright. Initially, I'm like, okay, I can split these up and combine them. So let's start with that. We can do that. Alright, 28 does not divide by 3, right? Yeah, in a moment. No. Okay, so that's not going to reduce, but this does. This will reduce to radical of a to the 4th. Yeah. So let's see. Radical 28 over 3. And I'm just going to go ahead and include these together. So 5 minus 1 is 4. So a to the 4th. Alright, then really I'm just left with a radical 3 on the bottom. So this is the same thing as if I had a radical 3 on the bottom. And really I could have skipped that step, as you can see. From here I could go ahead and eliminate that a right away, and that would be a little bit less work. But that's alright, there's always a way to get there. So now I want to get rid of the radical 3 on the bottom. So I want to multiply this by radical 3 and this by radical 3, giving me just 3 on the bottom. That's 28 times 3 is 84. Alright, let's go ahead and do the 84 in here. 2 and 21 looks like. See how I got decimals, so can't go that far. So 2 and 21. Alright, are we done? I see one more thing. We still got our a to the 4th, and that's a bigger number than what this is, so this is a 2, so I can take out groups of 2's from this, so I'm not done yet. So how many groups of 2 can come out of 4? 2. So I take out a to the 2nd, and I do not have any more left over, so my a's will go away. 2/3 doesn't reduce, so I think we're done. Let me check this just to make sure we're good. We got something wrong. Alright, let's figure it out. So actually that is the correct answer. One of the answer keys has the wrong answer, but my other one had the same answer, so this is, can't find any mistakes, so we're going to go with that. Alright, let's see what else we've got. Interesting. So now we're going to get into the, are we at the conjugate part yet? No, but I'm going to go ahead and show you kind of how to start one like this where you have a binomial in the numerator, because we haven't done that yet. So this is a binomial, this is a monomial. So we're going to start out, we want to get rid of this. So let's go ahead and multiply by the radical 12. Now, you might be wondering, oh, can I split this up and do this grouping over this grouping? And no, you cannot do that. You cannot split up any binomials or anything like that with just the denominator. That doesn't work. So don't do that, okay? Multiply by radical 12 over radical 12. So the denominator will just become 12, of course. However, the numerator, we now have a monomial times a binomial, and that means we've got to treat it like distributive property, okay? So we do have to do that. So we will multiply radical 12 times both of these items, and since it's under a radical, we'll just combine it under the radical with each of these terms. So that would be 3 radical, and if you want you can do this in your head, 2 times 12 is 24. Keep the same sign, plus, and then radical of 6 times 12, which is that 72? Yes, it is. Alright, so radical is out of the bottom, that's good, but we still have these radicals with big numbers, and I would guarantee that they simplify. So let's just simplify those in the calculator since I've got it already set up. So we're doing the square root of 24. Alright, we've got 2 and 6. Yeah, everything below this is decimals, so that becomes 2 radical 6. So 3 times 2 radical 6 on top plus, let's see what happens with that 72. Um, 3 and 8, but nope, not 3 and 8 because we've got this pair down here, 6 and 2. Alright. I think we're going to be able to reduce some stuff here. So 3 times 2 becomes 6, and I have a denominator of 12, and I have a coefficient of each term that can reduce with 12. So 6 and 12 will reduce to 1/2, so you don't have to keep the 1, but we know that the denominator is going to be 2, and you can only do this if both reduce by the same factor. So these all divide by 6, so we're good. If this one, for example, if this was like a 5, you wouldn't be able to do this because 5 and 12 don't reduce, okay? But if it was a 3, you could, because 3 and 12 reduce, and 6 and 12 reduce. But in this case, it's 1. So radical 6 plus, so that's 1. That also simplifies to a 1, so left with 2, and that divided by 6 and became a 2. So that is your solution. Now, be careful of this. You cannot add these and say, oh, that's radical 8. No. That is like with multiplying. I mean, you could, only if this was multiplication, you could put these together and multiply them. But you cannot add them because they're not like radicals. It's like x's. Like this is an x and this is a y in the math world. So you cannot just combine those, okay? So you would just leave it like that. Alright, let's do one that has the conjugate now, which would be in the denominator. So we had the binomial in the numerator, now we're going to have the binomial in the denominator. And this is a problem like what's described here as a binomial. So to get rid of it, you multiply by its conjugate. So for number 15, the conjugate of the denominator is 4 minus radical 2. So whatever we multiply on the bottom, we also have to multiply on the top. Alright, now this will be FOIL. 4 times 4 is 16 minus 4 times radical 2. It's just 4 radical 2. Alright, now the denominator, we have binomial times a binomial, which is FOIL, okay? We'll go ahead and do this step by step, but there will be a shortcut that we'll be able to do eventually. So 4 times 4 is 16. 4 times radical 2 is radical 2. 4 radical 2. Alright, this one times this one is also 4 radical 2, but a plus 4 radical 2. And then the last but not least, radical 2 times radical 2. And this is where it's going to cancel out. Okay, plus, minus. So a positive times a negative is a negative. And then a radical times itself is just that number, 2, without the square root. Okay, so this becomes minus 2. We have more that we can simplify on the bottom. So let's go ahead and write it out again. Feel free to write out as many steps as you can. We can also combine this. 16 minus 2. Let's go ahead and do that. Move the 2 over, and that would be a 14. And then this is what happens here. Minus 4 radical 2 plus 4 radical 2. So this is what's going to end up happening when you do this conjugate, is that whole middle section cancels out. That's it. Yeah, nice, huh? So that's going to happen. So the middle section, middle two terms will cancel out. So you're really just worried about the first pair and the last pair when you do this. So if you can remember that, you can feel free to skip writing that out. You don't have to write it out. All right, now, I see that I can reduce some items here. So again, you can reduce if the denominator is just a whole number, and then you can reduce both terms with the whole number. In this case, you can. So they all divide by, what, 2? Yeah. So everything, this, and this, and this, all divides by 2. So I can change this to an 8 minus 2. And the radical 2 will stay. So do not ever reduce that. Again, this is like a variable. This is like x. So you can't just simplify it with that as well. It's its own term. It's not a like. Not like, because it doesn't have a square root. And then this will become a 7. And that's it. Alright. So, let's see. If there's anything else kind of strange going on here. I don't think so. I think you'll be good. So this conjugate would be the same way. Just multiply it by the same term and change this to a minus. Do we need to do another one? I think we should be okay. Alright, why don't you go ahead and pause the video and try out these problems that we have skipped. So 11, 13, 16, and 17 through 20, and see how you do. And then press play when you are ready to see the answers. Good luck! Alright, let's wrap this up. So, let's go back and see answers. So number 11 is 3 times radical 21 divided by 14. And I went ahead and put the work for each of these. So if you want to pause the video and see the work, go ahead and do that. 13, the answer is 1. 16, 12 plus 2 radical 5 divided by 31. 17, radical 3 plus 4 radical 6 divided by negative 31. 18, and the numerator could be arranged differently as long as you have each term with the correct plus or minus in front of it. 5 radical 5 minus 5 radical 3 minus 5 plus radical 15. None of these can be combined because they're all different square roots, and all that divided by 2. Number 19, here's the work for this as well. So just to point out what I'm doing here, I'm doing 2 times 2 to get this denominator. I'm doing 2 times 2 is 4. Remember, I can skip the second term. I can skip the third term because they're going to cancel out. The fourth term is the last one times the last one, which is positive times a negative will always be a minus. And then 2 radical 7 times 2 radical 7. So I have to keep my 2's, and there are 2 of them. So 2 times 2 is why I have those 2's. And then radical 7 times itself will cancel out and just become a 7. So that's how I get this right here, giving me this. Now, when you get to this point, you have all 3 coefficients and terms are negative, so you can also divide by a negative to get rid of it, and then each one divides by 4. So I divided this by 4, negative 4, and got 2. This by negative 4 and got 1, so invisible, you don't have to write it. And then divide this by negative 4 and you get 6. And I went ahead and started 20, and I figured I'd go ahead and just go ahead and do this one with you. Just so if you need to see everything step by step again, here it is. So, again, these are multiplying by binomials, so I took the conjugate, I changed this to a plus, and then now I'm going to do first, outside, inside, last. So 8 times 3 is 24. That's the first. Then I do 8 times the last term over here. 8 will combine with a 4 because it doesn't have a square root. So that's plus 32 radical 6. And then I do radical 6 times 3, which has a minus in front of it. So the 3 will stay out front. Then one last term. A negative times a positive is a negative. So do one thing at a time. Don't rush. And then this times 4 radical 6, so that will go under the radical. That's 4 radical of 36. And I'll simplify that in a second. Alright, now for the denominator is always going to cancel out. The 2 middle terms will cancel out. So all I'm worried about is the first term and the last term. So the first term will be 9. And then the last term will be this times itself. So it'll be minus, positive times a negative. And then I look at this and I say, okay, what are my coefficient terms are 4 and 4, so I'm minusing 4 times, and then this is where your square root goes away. Radical 6 times radical 6. It's just 6. Alright. Let's go ahead down here. Let's see, do I know I have anything that'll combine? I think this right here is. So this radical 36 is going to change to a 6. So 6 times 4 is 24. So I really have minus 24. Ooh, interesting. So that's going to go away on my next line. I can also subtract these. 32 minus 3 because they both have the same radical. So 32 minus 3 is 29. But positive minus will still be a positive. So that's 29. Radical 6. I already took care of that over there. 9 minus 4 times 4 is 16. 16 times 6 is 96. Alright, and then from there, I have 24 minus 24 becomes 0. So I just have that, and this has no perfect squares in it. But 9 minus 96 is negative 87. So only thing I might be able to do is divide 29 and 87. Let's see if they simplify. So 29 divided by 87, math, enter, enter, and I'm doing this in the handheld calculator. That's the one function that Desmos does not have, is simplifying fractions. And so that's kind of not great. So you just have to trial and error when you're using Desmos. But 29 over 87 does reduce, so the regular calculator does give me 1 over 3. So this reduces to 1 over 3. So we can have radical 6 divided by 3, and then the negative can just be anywhere. Just put it one negative sign somewhere. You can keep it in the bottom, put it to the top, put it in the middle. Not a big deal. But that is the answer. Okay, so that's it for this section. That's dividing. Yeah, that can be kind of tricky. A lot of work, tedious work, but important stuff. So, see you next time.